Drinking water treatment is basically the process of producing pure water for human consumption without any negative health effects by removing contaminants such as viruses and iron from the raw water sources. Generally, there are many ways to treat water, and in this video, we'll be talking about the ozone treatment. But first, where does ozone being used to treat water? Ozone was first used in water treatment in the late 1800s and is more widely used in Europe and Asia than the United States. The first drinking water plant with ozone was built in Nice, France in 1906. We will explain even further about the history of ozone water treatment later on. Ozone is also used for industrial water treatment processes in large swimming pools and aquariums, and also in municipal wastewater applications for direct and indirect potable reuse processes. This leads us to why ozone treatment is being used. Well, first of all, it has a greater disinfection effectiveness against bacteria and viruses compared to chlorination. In addition, the oxidizing properties of ozone can reduce the concentration of iron, manganese, sulfur, and reduce or eliminate taste and odor problems. It also oxidizes the iron, manganese, and sulfur in the water to form insoluble metal oxides or elemental sulfur, which will then be removed by post-filtration, in which my colleague will explain even further on the operations later on.
So here is the history of the ozone in drinking water treatment. Van Mierum, who was once a Dutch chemist, was likely to be the first person for ozone gas detection. Yet, as in Schonbein's writing in 1840, the finding of ozone was only being brought up by name decades later. Van Mierum once in the past tried to recognize the characteristic smell around his electrifier, whereby the same characteristic was observed by Schonbein through his experiments. The sand word from Greek has made the existence of ozone name for the gas. In general, Schonbein was mentioned to be attributed to the finding of ozone, whereby he was also being recognized as the earliest person in the reaction mechanisms of ozone and organic matter research. Therefore, the number of research for the disinfection mechanism of ozone has risen after 1840. Berlin was recognized being the first state of Germany involved in the first ozone generator invented by von Siemens. Von Siemens was also the writer of a book that tells about ozone application in water. Other than that, there was also a French chemist and a doctoral graduate from French University named Maurice Poluto that recognized as the first person to initialize the company for the ozone installations manufacturing.
In 1893, the French scientists had installed the first technical scale application of ozone in Uithoorn, Netherlands. In 1906, the other installation was in Nice until the following years, which resulted in Nice being recognized as the place of birth of ozone for drinking water treatment. There was a rising number of ozone installations in many countries before the beginning of World War I. Nevertheless, the number of installations was decreasing as there was a finding of toxic gases. After the World War II, ozone production has increased again. But today, chlorine is more preferable to ozone for water disinfection. Yet, the scientists still working on research about alternative disinfection, as there was once in 1973 pop up the discovery of trihalomethanes as a harmful disinfection byproduct of chlorine disinfection.
Let's move on to the ozonation process. The formation of oxygen into ozone occurs with the use of energy. This process is carried out by an electric discharge field as in the 3D type ozone generator, which is coronal discharge simulation of the lightning, or by the ultraviolet radiation as in the UV type ozone generator, which is a simulation of the ultraviolet rays from the sun. In addition to these commercial methods, ozone may also be made through electrolytic and chemical reaction. In general, an ozonation system includes passing dry clean air through a high voltage electric discharge. In treating small quantities of waste, the UV ozonation is the most common large-scale system used in the coronal discharge or other bulk ozone producing method. So let's move on to the process. Ozone generator will produce ozone. Then the ozone injector will create micro bubbles which will increase the stability of ozone in the groundwater. After that, ozone is dissolved in water at the storage tank, which will produce highly ozonated water that is used to control bacteria, and water is being treated. Since the ozone will react with metal to create insoluble metal oxide, post-filtration is required before entering the house.
Advantages and disadvantages of ozone in water treatment. When looking at the ozonation process, there are numerous advantages that come with using this process to purify water, which include the treatment process occurs without adding any kind of chemicals to the water. Besides, ozonation eliminates many impurities in water as well as a wide variety of inorganic, organic and microbiological problems. Also, ozone is very strong oxidizing power with a short reaction time, thus requires significantly less contact time to remove inorganic and organic compounds. However, there are also numerous disadvantages of ozonation that we should take into account, which include the operation and equipment costs for ozonation are relatively high and require consistent maintenance. Next, ozone is less soluble in water compared to chlorine, and therefore, special mixing techniques will need to be used in order to dissolve properly. Besides, ozonation provides no residual disinfection elements which can regrowth of the bacteria or viruses. Also, generating ozone may lead to potential fire hazards and toxicity issues. Lastly, ozonation byproducts are still being evaluated for the possibility to be carcinogenic. This may include brominated byproduct, aldehyde, ketones, and carboxylic acid.
In conclusion, all types of water treatment have the same objectives of making sure that the water is safe to drink and aesthetically acceptable for drinking, as we always want the best. So the water agencies, large and small, want to provide their customers with the highest quality drinking water in the world. Large scale of ozone technology is now well established, and its reliability and efficiency are improving rapidly. As the technology has no residual disinfection effect, its application must be combined with secondary disinfectant to maintain a residual in the distribution system. Although it has high operation and equipment costs, its power is in killing most microorganisms, oxidizing metallic ions, and degrading pollutants such as micropollutants. In fact, ozone treatment is a very efficient and fast method for disinfection. However, it also needs a precise monitoring and dosing adjustment of ozone, as well as skilled staff and high-tech equipment to ensure the efficiency of the treatment. With that, thank you.